Assalamualaikum and salam sejahtera. We are from Group 8 and we will present about shortest remaining time first. My group member is Nik Muhammad Akil bin Ghazaki, Munirah binti Muhammad Hanifiah, Nur Farah Wahidah binti Zulkifli, and last Sharifah Shahmira binti Shah Said. We will start first about introduction for shortest remaining time first.
Assalamualaikum dan salam sejahtera. Hari ini saya akan bentangkan mengenai Introduction Shortest Remaining Time First, SRTF. Poin yang pertama, Shortest Remaining Time, also known as Shortest Remaining Time First, is a scheduling method that is a preemptive version of shortest job next scheduling. In this scheduling algorithm, the process with the smaller amount of time remaining until completion is selected to execute. Since the currently executing process is the one with the shortest amount of time remaining by definition, and since that time should only reduce as execution progresses, the process will either run until it completes or get preempted if a new process is added that requires a smaller amount of time. Poin yang kedua, shortest remaining time is advantageous because short processes are handled very quickly. The system also requires very little overhead since it only makes a decision when a process completes or a new process is added. And when a new process is added, the algorithm only needs to compare the currently executing process with the new process, ignoring all other processes currently waiting to execute. Poin yang ketiga, like shorter job next, it has the potential for process starvation. Long processes may be held off indefinitely if short processes are continually added. This trait can be minimal when the process time follows a heavy tiled distribution. A similar algorithm which avoids starvation at the cost of higher tracking overhead is higher response ratio next, HRRN. Sekian, terima kasih.
Okay, so next I will talk about advantage and disadvantage for shortest remaining time first. The first advantage is processing of the job for SRTF is more faster than shortest job first. The second advantage is in SRTF, process with shortest bus time will run fast compared to the others. For example, a bus time for the task 1 is 3. Then the second task, the bus time is 1. So the process we will start with task 2 first because the bus time for task 2 is 1 but the task 1 the bus time is 3. The third advantage is in SRTF we will get increased throughput. The last advantage is SRTF is always used in batch system where we have to give preference to shortest job first. Next is about disadvantage. The first disadvantage is in SRTF, it is impossible to implement SRTF scheduling algorithm in interactive system. It is because we don't know the required CPU time here. The second disadvantage is the process which has a long burst time need to wait a little bit more. This is because the process with short burst time are being executed by the CPU first. The last disadvantage is in SRTF we cannot predict the burst time correctly.
Okay, this is the coding for shortest remaining time first, which called as SRTF in operating system. Okay, let's run the program to see its output. Okay, this coding allows us to input data Okay, at first it asks, please enter the number of processes. Let's say we put 5 processes. And then it asks, please enter the arrival time for process 1. You can put any number or a number that you would like to try. So I would like to follow this scheduling example from the internet. Okay, the process P1, the arrival time is 3, burst time is 1, and process P2, arrival time is 1, burst time is 4, while process P3, arrival time is 4, burst time is 2, and P4, arrival time is 0, burst time is 6, and the last one, process P5, the arrival time is 2, and burst time is 3. So there's also output for Gantt chart for this scheduling. Okay, as you can see, it also match with the Gantt chart from the internet. Okay, at time 0, P4 gets executed first, followed by P2 at time 1, and then P1, and then P2, P3, and P5, and P4. Okay, and there's also a table of process, arrival time, burst time, waiting time, and turnaround time. Okay, the waiting time for process 1 is 0, waiting time for process 2 is 1, waiting time for process 3 is 2, while waiting time for process 4 is 10, and the last one, waiting time for process 5 is 6. For the turnaround time, process 1 is 1, process 2 is 5, process 3 is 4, process 4 is 16, and the last one, process 5 is 9. Okay, so the average waiting time for this scheduling is 3.8, and the average turnaround time is 7.0 ms. Okay, so it shows that our code for shortest remaining time first is the algorithm to find the shortest remaining time first in a program. Okay, thank you. Hi, my name is Shamira, and I would like to continue with discussion. At the beginning of Srtf, which called shortest remaining time first in the Java program, it allows user to input the total number of processes. And then user can input the specific burst time and arrival time for the CPU processes. So all the data will be kept in variable pro, which is into the array code. Okay, so the first row of 2D array code is for process number. And then the second row is for arrival time. And then the third row is for burst time. And then the fourth row is for waiting time, while the last row is for turnaround time. Okay, then the next for looping in the Java program is to calculate the time chart array, which calculate the total time for all processes in the CPU process based on their burst time. Okay, then the third loop in this Java program is to display the Gantt chart for the scheduling, where it selects the shortest processes which has arrived and stored in the array. So it sorts all the process in order from the shortest process to the longest process of the scheduling. So the algorithm will pick P1 first because it has the shortest time, and then P2 followed by P4, and then P1, and then P3 as the arrangement of the Gantt chart of the scheduling, because the algorithm checks which one has the shortest time first. Okay, as for the description, at the 0 unit of the CPU process, there's only one process has arrived, which is P1. So P1 gets executed first. And then process P2 has arrived at the first unit of the CPU process. Now, the process of P1 still needs 7 more units to be executed, while process P2 only needs P2 unit for its execution. That's why the algorithm choose P2 for the next execution. Okay, the algorithm undergoes the remaining time of the selected process by 1 since it has been assigned to the CPU process for 1 unit of the time. Okay, and then P3 has arrived at the second unit of the CPU, while P4 has arrived at the third unit of the CPU. Okay, and then, but these two processes has longer remaining time compared to process P2. So P2 continue its execution because P2 only have 4 seconds of a burst time. Okay, after P2 has finally get executed at the fifth unit of the CPU process, and then the algorithm will check the remaining time for process P1, P3, and P4. Which one has the shortest remaining time to get executed first? Okay, P1 still have 7 remaining time, and then P3 have 9 remaining time, and then for the P4, it have 5 remaining time. So at the fifth unit of the CPU, process P4 will continue the execution process. So P4 get executed first and finish at the 10th unit of the CPU. Then continue with the process of P1 until 17 units of CPU scheduling. Lastly, P3 get executed for 9 seconds where it finished at 26 unit of the CPU scheduling. Following by the calculation of waiting time and turnaround time in the algorithm, there are 3 conditions to calculate the times, which the first one, if the process has arrived and it has not already completed execution. So the turnaround time is incremented by 1. Next, if the process has not been currently assigned to the CPU and has arrived, its waiting time is incremented by 1. Last one, if is the special case where the process has been assigned to the CPU and has completed its execution. So, the codes automatically add the waiting time and turnaround time if the processes is not complete yet. Last but not least, the last for loop in the algorithm is to calculate the average of waiting time and turnaround time by adding all the value of turnaround time and then divide by the total process, while the waiting time add all the value of waiting time in the array and divide the with the total process in the scheduling. That's all.
In this scheduling algorithm, the first process that will be executed is the process with the smallest amount of the time remaining. It is because the time is reduced as the execution progresses, and the currently executing process has the smallest amount of time remaining that will make the process will always run until its completion, or by adding new process that has a smaller amount of remaining time. A threat like process starvation happens when short processes are continually added. The long process may be head off indefinitely. They are commonly happens in shortest job first. This threat can be minimal when process time follow a heavy tail distributions. Shortest time remaining first scheduling is rarely used outside of specialized environments because it requires an accurate estimation of the runtime of a processes they are waiting for its executions. Thank you.